Great. Okay, so the name of the project is Tiled. This is going to be a live demo, just a couple of slides to start, set it up. For data portals, think like web portals, and data science. This is a very new work, and we're still in the process of understanding all the ways in which this fits into the bigger picture. At the same time, we do think there's definitely a good idea in here, and we're running with it. So at the end, I'd like to ask you, are we missing any opportunities in the way that we're framing the problem that we think we're solving? Is there related work that we should know about and align with or incorporate ideas from? And what use cases do you have that we should be aiming for in the coming weeks or the coming years? Are you interested in working with us on that? So we'll get to that during the discussion. The name of the game is improving data access by leveraging standards from the web side of the technical world and the scientific computing side and matching them to meet our users' needs. We're meeting our users where they are by having one foot in the sort of traditional file-based data access world and one foot in more forward-looking, and in some cases, present, in some cases, speculative ways of accessing data at user facilities. So as I say, it's a very new project. The first line of code was February a year ago. It's building, though, on 6 years of thinking about these problems in building Data Broker with a similar team. Now, the project has benefited from dozens of hours of conversation with Stuart, Tom, Dylan, and it's built on some open source collaborative work with industry. What I'm going to show you today is all about reading data, accessing data, but we see a very clear path to also writing data, saving data through this same technology. And Juan and Joe are funded through a BES AI/ML grant led by Eli Stavitsky to add that data saving capability. We're especially interested in capturing analysis results and richer search capabilities on that as well. So in order to meet our users' needs, we really need to be unopinionated about file formats. And that's on both sides of the equation, right? We need to not have a strong opinion about how data is stored, nor have a strong opinion about how data is ultimately presented to the users. Therefore, Tiled can potentially read data in just about any way. It could be taught to read many different formats. It knows a lot of the common ones that we use already, like CSV, Nexus, and so on. It can connect to databases, such as the ones that Blue Sky uses or other databases, and data services, think like web resources or data caches like Materials Project, for example. Tiled can read data from all of these things, and it can then present the data to the user in a variety of different formats. If you're a web portal, you may want an image format or some text. If you're a more sophisticated programming language like Python or Julia, you may have a deeper integration and want to be grabbing the data in compressed binary chunks that you can efficiently represent in NumPy arrays or other high-performance structures for data analysis, including but not limited to machine learning. If you're just trying to get a file, you may want to run wget or curl and have some URL that can download your data as a file, and then you go open it in some other program. And Tiled can do all of these things. Now, you don't need to be a data person, per se, to spot a combinatorial issue in this promise, right? How are you going to get from n different ways of storing the data to n different ways to getting it? That kind of sounds like a lot of code. And the key idea that makes Tiled tractable is that the number of actual structures that we have to deal with at user facilities is not that many. That at the end of the day, everything is basically an array. It could be a multi-dimensional array, or a table, or some hierarchical structure of those, like a Nexus file, HDF5 file, or a directory of TIFFs, for example. So array, table, hierarchy of one of those is more or less all we have. And then attached to that, some dictionary, some key value mapping of metadata. And you can get more specialized. You can say, well, my table isn't just any table. It's the XDI table with certain columns that are conventional in XAS, for example. Or my array isn't any array. It's specifically an array that came from area detector that we know has these properties. But if you can boil it down to, at the bottom, these common structures, this unlocks a lot of problems and makes it possible to do the things that I will show. So we're starting from the status quo. Status quo is file browsers, not that different from the file browsers that you use when you're looking at files on your own computer. You could think of Apache web servers shown in the bottom right of the slide. You think of FTP, think of Globus, think of Rusio if you use that. These are all ultimately file browsers that treat the file as a black box. And that means that whatever format the data is written in, which may not be the format that the user wants to read, is the format you're sort of stuck with. And if you've got users who can't read whose analysis program can't read the format that your vendor writes from their detector, then you're in the business of keeping a bunch of copies of that file around. And I hear from Beamline staff who have to translate their data into 6 different bespoke text formats for 6 different groups that want it in a particular way. You also can't get partial access generally to this data, right? If you want to look at a frame inside a Nexus file, you have to download the whole file first and then open it. You can't say, show me, download just this one frame. That makes it hard to do things like galleries where you're looking quickly through many scans, or longitudinal analyses that are going to grab just a little bit of many sets of data. It's also not easy to express relationships between data inside different files. So saying that image X from this area detector output is correlated with temperature point or motor position Y inside this spec file is a hard thing to express for a file server. And then finally, maybe as a more cosmetic point, if your data is stored in some format that web browsers like Chrome and Firefox don't natively know, there's no way to easily preview that in a web browser. Now, when I talk about web stuff, and I show that diagram that I showed, I worry that this could feel like it's something you can't really get your hands around, that it's a bit distant. We don't want to conflate web technology with cloud technology. If you use Jupyter, you know that web technology can be something that runs on your lab server or on your laptop. It's something you can use in a small environment as just a personal tool. It's not necessarily something you need an IT department to set up for you. As an example, and I will show this very last thing in the demo, you can install Tiled, and then you can point it at a directory of files. And if there are files that Tiled already knows about, like CSV, Nexus, etc., Excel, TIFF, then it may just work straight out of the box. And now you have a web browser experience for browsing your data and a way to efficiently load it into Python or any internet-connected program. That's sort of the small scale a graduate student could do this use case. Now, we can also scale it up. We have a facility-wide deployment that we've been running for about 6 months at tiled.nslS2.bnl.gov. That's inside our firewall. And we've used it on just a handful of user experiments for remote analysis and remote data processing. And it's been pretty cool. I think a point I really want to drive home, and I want you to consider what you might do with this, is that we have, at least in principle, a way to get a URL to every piece of data at NSLS-II. And that means not just to the scan, but to a specific, possibly multidimensional region of interest inside an image, or a specific range of points in a column from some scan. I think there's a lot of potential from that level of granularity we can get to the data. As I say, we can get the data into many different formats. So let's just talk through some examples to make that concrete. If you've got some custom one-off text format that works with a 30-year-old bash script that you don't really feel like changing because it still works, Tiled can be taught to write into that format. I'll show you where the documentation is before we end. If you've got software like PyMCA, ImageJ, Origin, Igor, these things read files. They don't know how to connect to fancy data services. Then you can get Tiled to write those files that can be opened by your software. You may be able to hand some software a URL directly, and it can then read the data straight in. We can get web-friendly formats to be displayed by web applications. And then sort of at the most high end, we can get chunks of binary data that can be fetched in parallel and fed straight into data science tools. So in summary, we believe this tool can meet all of the users where they are and help them get to where they want to be without any disruptive changes to their workflow. So if we take a step back, what we're really doing is separating how data is stored from how it is accessed. If you think back to that diagram, Tiled is in the middle, kind of hiding how the data is actually being saved from the way that the users experience it and letting different users grab it in different ways. So this gives us easy access across the internet from Python, web browsers, any internet connected software. And it makes it practical to comply with the so-called FAIR principles of data access. I think these are things that we all, in principle, agree are a good idea, but it's hard to make contact with it in practice. How do I really make my data open in a practical way. And I think that tiled, by giving lots of ways for users to get at data, and by giving these granular URLs to data, makes that achievable in a new way. Again, we can request the data in any appropriate format, and we can teach tiled new formats without too much trouble. And that now opens up for people on the data side of the house, like me, the freedom to experiment a little bit. Like, could we make this faster by experimenting with newer formats for area detector than HDF5? Things like cloud blob storage. And normally making a change like that means that all of the science code would have to be updated, which may not be feasible. But by putting tiled in the middle, we can make the file storage faster and more modern, and try things and then decide they were good or bad ideas, and move all this around without breaking the user's contract, without breaking how they receive the data. I just want to flash this slide with too much text on it to say we're trying to be very uncreative in the way that we're being creative. We're trying to bolt together rock solid existing standards that any other practitioner would recognize in a way that meets our users' needs, spanning how we deal with monitoring the performance, to what formats we use and how we spell them, and especially security, where originality is generally discouraged. We've been shopping this around and getting feedback from many different groups over the last year, looking to better understand what we're doing and how it fits into what other people are doing. There is a lot of interest in this idea of baking data down to structures and providing a structured way to access data over the web in particular. We know Microsoft, Amazon, Google, NASA all have work going on in this space, but they tend to be targeting something a little different. They're typically hitting a specific kind of data set, like say a climate observation data set. And what makes our needs a little unique is that we have such a wide span of data sizes, data rates, scientific analysis that's being done, structures that are being used, that I think we need to look at those efforts and align with them, but have our own thing that meets the particular challenges of the user facility. Mentioned in particular, Diamond has one FTE specifically looking at integrating with tiled to bridge the growing Python work that they're doing at Diamond with the existing GDA in Java. So tiled as a bridge between the old and the new has some validation there. So with that, I'm going to switch to a demo, but I'm going to stay in my web browser. Do you see a web page with some purple buttons on it?
Yes.
Great. Okay. So this is tiledemo.blueskyproject.io. And we're going to look at data a couple different ways. We can access it through the web browser. We can access it through Python. And these are all going to talk to the tiled web server. So we'll start here. And this just made a web request to the tiled server to list the data sets that are available. We have some simulated data and then data from 2 beamlines that have been designated, just a couple open data sets that we can look at here. So we'll start with generated because it's nice and simple. If I have a really big image, this user interface can fetch it and show it to me as a PNG, and it can be smart enough to downsample it. And it's not just shrinking it to fit my browser, it's actually requesting every 9th pixel in every dimension to download a reasonable amount of data and quickly show it in my browser. This is something that you couldn't do with just a file-based server. Only something that opens the files and understands their structure can give you a feature like that. Chrome can also easily show us what this looked like on a phone. And so now it's been even further downsampled and loaded less data to show us a mobile view of the same content. Let's go back up here and let's look at a small image that's obviously smaller. And we can go to the download tab and see that tiled is willing to translate this into a range of formats that are appropriate for images. So we could say, all right, I want a PNG image. Downloads that as a file that I could open with any program. Link makes a link. You can see the format indicated in that link. And open will open this in another browser tab, which actually only works if it's a format that the browser can open. I can get a little fancy, and by consulting these examples, try to use NumPy style slicing on this array. So say, I actually only care about the first 10 pixels in that dimension and the last 50 pixels. Oops, there we go. I can't do math under pressure. We'll do the first 50 pixels in that dimension. Is that valid NumPy syntax? Yes. Okay, so I could download that. I could link to that. We could see that the slice is now part of that URL. Here's a URL to this specific data. And if I open it, now we see just a little chunk. all the more important if this were a giant image, I suppose. Okay, now we're going to look at this guy. This is a short table as advertised. And I can look at a specific column in this table, which is just a 1D array. 1D arrays can be plotted, or we could look at some list of the numbers, and I can adjust again which slice of this data I'm actually interested in. Let me close that tab. Look at what I'm actually interested in here. Actually, back to that. Now, there's a limit to what you can do, right? This is not going to grow into a data visualization program or analysis program. I think it's too much to dream that we could fit all of that into one web app. So at this point, you want to go and download this table, maybe as a CSV. We can see again a link, and I can go in and say, I actually only want to pay to download these two columns because that's what I care about right now. And now those two columns show up in my URL. And I'm going to first look at this as a web page. So we'll go ahead and open that. Here's a quick and dirty web page with that data in it. And if I grab this link, I could say I'm going to try and load this into a data analysis program that I have, like Plotly Chart Studio. We'll make a chart in Plotly Chart Studio. Chart Studio doesn't know or care anything about tiled, but it does understand what a CSV file is. So if I give it this URL, oops, I got to remember to tell it to get CSV. Hang on, back to tiled, CSV, copy, back to Plotly. Oh, actually it was able to load that HTML data. I think we could do CSV as well. And there we go. So I got my two columns of data, and I could plot A versus C and get a scatter plot. So this goes to show that tiled can bridge the data into another program that does not know or care about tiled by translating it from however it's stored. In this case, this I don't even remember how this is stored. Translated into CSV for Plotly. Now let's go get some beamline data. I think we've exhausted the generated data. So I'm walking through the BMM list of public scans here. I can tweak which columns I want to see. If I don't care about Blue Sky Plan, I can get rid of that. I could show the fully unique ID. Look at the time. That could be prettier, but it's all there. And we'll look at the scan. Whoops. This is very nested because it comes from Blue Sky. So we're just digging in, and now here's the stuff we want. So I could look at the DCM energy, for example, and I could go and download that in a range of formats if I want. Look at the metadata. Maybe go back up to here, look at some more metadata. We can see everything that BMM captured about this scan. Next, let's look at FXI. They have some tomography image data. So we'll look at this. We'll again jump through all of the nestedness of Blue Sky and end up with this image. Here's a 4D array. So this is this cannot give us a 4D display in the browser right now, but it can give us sliders for extra dimensions, showing 2 dimensions of the image here. And then this would be the number of time points in a given point in the scan, and then this would be points in the scan. You can see it's also downsampled it. And if I move this slider, we get updates to the data. And again, I could go and try to download them as various formats. Now, we've reached the limits, I think, of what we can do here to actually analyze this data. As I said, we want to go to another program like Plotly, or download it and open it in maybe Igor or something. I can also just go straight to Python and connect using the Python tiled client. If you pip install the tiled client, you can now connect to a data source from its URL like this, look at what's in there, and you can see the same things that we were seeing in the web app. This is accessing that same data, but it's accessing it in a more efficient way. Rather than asking for image files, it's now going to ask for compressed binary blobs that it can download to produce a data set like this. So I'll actually go ahead and run this. Let me clear all outputs. So I'm accessing a specific scan. You might ask how I need to type that. Let me walk this in one at a time. So here's BMM. Okay, it just has raw data. Maybe we'll add process data someday. And here's a list of some scan IDs. There's 123 of them. Now I just pick this one off, put that in, grab a data set. And at this point, we've left tiled. So if you know Xarray is a popular data science library, tiled has produced an Xarray data set with the data in it. And now you don't need to know anything about tiled. You've just got an Xarray data set. So one thing I could do is plot the log of I0 over IT versus DCM energy. And that should give you a flavor of how you would use this. So the last thing I want to show, let's see, is sharing a different window. Okay, what I want to show you is that you can serve your own files through this and do this sort of hands-on local use case. So I've got some example files. Can you see my terminal, by the way? Kara, can you shout out, or someone?
Yes.
Yes.
Okay, great.
Bigger.
Font bigger, yep. Pop, pop, pop. So I've got some example files. There's a Nexus file in here I got from Pete Jemian, a CSV file, some TIFFs, an Excel file, and I can ask tiled to serve that by just saying tiled serve directory, and then the path to my directory. And what it will give me is two URLs, one that I could put in a web browser and one that I could give to Python. So we'll come back to the web browser. And I'm going to paste this in. So this is now a local URL, not the public tiled demo, but my local machine. And just like Jupyter, if you've typed Jupyter Notebook, you might have noticed it gives you a gibberish password that it generates. This means that other people with access to my machine can't snoop on my data unless I let them. And now we've got another version of this web interface. But when we navigate through it, we're looking at the files on my computer. So this is a black TIFF file. Let's look at the Nexus file. Gotta love Nexus. Also, like Blue Sky, very nested. Data. There we go. There's a pattern. Generated as PNG for me. I could go in and ask for that in any format. I could slice it. So let's say I just want the top left again. And let's grab that as a PNG image. I haven't actually tried this. Let's see if this, yep, that works. So there's a little chunk of those rings. This is all just on my files. Didn't do anything special to tell tiled about these particular files. We could go in and look at Excel. Excel is also a hierarchical structure because an Excel file can have multiple spreadsheets. So here's the node for each spreadsheet, and then here's the actual data. Coming back to Python, coming back to the terminal. Boom. I can now start IPython, import the tiled client library. Let me bump that font size again. I'm going to go back here. You can see, by the way, these are server logs showing all the requests that the web page made to get the chunks of data that it wanted. Here's the URL to connect from Python. Paste. And now we can see a dictionary-like structure. And it feels like a dictionary, or you could say it feels like maybe H5Py if you've used that. And once we get down to this array, I can say, give me all the data, or give me just some of the data, and you get the idea. So one last thing to show. I know I'm a little past 25 minutes here. I want to point out that the landing page of this also has a link to the documentation at the very bottom. So if you want to follow that again on how to serve some files, you can see serve a directory of files on this documentation page. If you want to learn how to be able to download those files in custom formats, you can see add a custom export format. For example, everybody knows how to write CSV files, and tiled can certainly do that out of the box. But what if you have an analysis code that needs emoji separated variable files? Now you know how to do that. And having reached emoji separated variables, I will turn it over to questions and discussion. Coming back to these slides as a prompt. And Kara, would you drop these links in the chat?
Yeah, I will do that. Thank you so much for the talk, Dan.
Sure.
Let me stop the recording here.